We're recording now, so you better be good. So
No,
the area of
no.
a triangle, I know you know the area of a triangle is base times height divided by 2, right? You said, why are we learning this now? Because you can find, and that's only if you know the base and the height, but you can find the area of a triangle directly without knowing the height by using, by applying SOHCAHTOA. So you know that the sine of theta over here is equal to what over what, if I look at this picture? H over A, right? So that must mean that that A, or H, equals whoops, my finger, it's not working, A sine theta, right? So now what I can do is I can take that H and substitute it in to this equation, and I get that area of any triangle, area is equal to A, B sine theta divided by 2. Okay? But this does have to be an acute angle, okay? Because if it's not an acute angle, then sine of an obtuse angle. No, it still works if it's an obtuse angle.
You're spreading slender, Mr. Leader.
Does it still work if it's an obtuse angle? Yeah, it still works. Okay? So, so never mind. So then you just plug into that formula and you'll get the answer. So for instance, if this side is for an obtuse triangle, let's draw an obtuse triangle because it does work for obtuse triangle. So for instance, say you draw an obtuse triangle.
Can you go back to the next page with that formula?
What?
Can you go back to the last page with that formula?
Yeah. A, B, sine theta. So A and B are the sides surrounding the angle, and theta is the angle in between those two sides. Okay. So going back, then say for instance I have this triangle right here, where this is 4, and this is 5, and this is 120 degrees just for kicks. And they say find the area. So all you have to do for that is plug and chug. 4 times 5 times the sine of 120 divided by 2. And I made this be an angle which you should know the sine or cosine of. Do you guys remember what the sine of 120 is?
Is it like 1?
Is it like 1? No. If it's like 1, it's a number just like 1, but it's not 1. Okay. Okay. Is it negative 1/2? Oh, it's a positive number. Positive square root of 3 over 2. Okay. So when I simplify that, you can cancel this with this. Okay. That's 10. And I get 10 root of 3 over 2, which is the same as 5 square root of 3, whatever the square units happen to at the time. Okay? All right.
So it's not something we would plug into a calculator?
Well, usually it will be. It's just that this is an exact answer, so it comes out okay. All right? But if this were like 113, then yeah, you'd have to plug it into a calculator. Okay? And then the next thing, what's wrong? Why is this 2 still there? Because sine of 120 is root of 3 over 2. 4 times 5 is 20, and I canceled this 2 with that 20, right? Okay? Very good.
So wait, I have a question.
Yes?
Does that 2, like, we simplified it to 10 root 3 over 2, is that 2 supposed to be applied to the 10 also?
Is that 2?
No, because when you multiply fractions, you're just too tough and bottom.
Why is it this movie? Say that again? Amen?
That 2. Is that supposed to be there under that?
Is this 2 Is this 2 supposed to be here?
Yeah,
Yeah.
the root be over 2.
Oh!
But like, is it supposed to be under the 10?
Well,
Cancel out.
I canceled out this 2
I know, I
with the
did
20, so
that.
that's 10. But this 2 is still here.
Oh, yeah.
right?
Yeah.
You multiply the 10
When you
times
multiply
around.
Right, so it's
fractions, you
10
just do
times
10
square root
times
3
the square
over
root
2,
of
which
three.
is 5 roots. That's right. Yeah, I only, you don't cancel it out. Only one of those. There's 2 2s here, right? There's this 2, and then there's that 2. Right? And only one of
You can
them.
move that second
Mr.
two.
Leader, can you
Yeah,
can
you can
you
move this
Now you
in.
can-
this formula for a real life application of figuring out how many tacos you can fit through a lampshade?
No. All right.
Or do you have to use
So,
an integral?
moving on. Come on. You guys are messing up my video here. Okay. Then we have something called Heron's formula. Have you heard of Heron's formula?
No.
Okay. So Heron's formula says that if you have a triangle with sides A, B, and C, and this kind of, they get this, I believe, out of the law of cosines. You can look at the derivation in your book.
Don't they get the law
But-
of cosines out into the
But given 3 sides of a triangle, you can find the area.
Wait, what's this
Right.
thing called?
Oh, this is called Heron's formula. Heron formula. And you may have seen this in geometry. Sometimes your geometry teacher teaches you this. I do sometimes. Okay? And that's equal to the square root of s times s minus a times s minus b. We're going to tell you in a minute. Times s minus c. And at where s is 1/2 of a plus b plus c. Okay, it's basically 1/2 of the perimeter. So for instance, say you have this triangle, and they tell you that this side is 11, and this side, even though it doesn't look like it, is 4, and this side over here is 13. And they say find the area. Well, you could drop down a height, and then what could you do? You can find this angle, and use a lot of cosines to find the height and all that stuff. But it's find the angle, and then use a lot of sines or SOHCAHTOA to find the height. But that's kind of a pain in the neck. So we could just plug right into Heron's formula. So you know that a plus b plus c, which is divided by 2 times 1/2, is going to be, what's that, 15? 50 plus 13 is 28, so that comes out to be 14, right? Did I do that right?
Yeah.
Yeah. So that's 14. So the area is just going to be the square root of s, which is, this is s, right? S, which is 14. S minus a is 3. S minus b is 10. And s minus c is 1, right? So you get a equals the square root of 14 times 30. 14 times 30, which I believe is the square root of 420, is that right? 420. And then you just, if they ask for an approximate answer, that comes out to be about 30. It's not 30? What does that come out as? 14, 10 times. I did that right?
Yeah.
So the square root, so then you just plug that into your calculator. Whoops, it's wrong.
Yeah,
How much?
20.5.
About 20, 25, whatever your units happen to be. Maybe they're squinches. Inches. Okay. Squinches.
What's a
Square-
squinch?
A square. So a squinch is, so that is, what's, okay, so your homework, that's all I have to teach you. Is, page 552, 1 through 5, 11, 17, 23, 33, 37, and 40. Okay? And remember, you heard it here on roller derby.
Roller derby?